We have already started basically on functor class. So previous class Devasis, I think sir you are also present there in the class.
Yes, Prasanna sir, I was present.
Yeah, Sohan is not there. So let's repeat the functor again so that he can also learn actually what is a functor. Sohan, one of the questions arise for you. So till now you have already basic knowledge on Haskell.
Yes, sir.
So just give an example of a map. What is map? Previous class, Nanda sir told you about map. Can you just give an example? What is a map? Just tell me what is map?
Mapping with a key pair to a value.
Okay, very good. In Haskell, what is the map?
Can't recall the exact definition.
Okay, it's not. I'm not asking about the definition. Just what you have. Previous classes we have already covered the map. So you have also doubt. You have asked some questions regarding map.
Yes.
So I just recall it. So all of you, we can recall that what is basically map. So we all know that what is a map. So kind of whatever you told is that map is a basically a key to a list. Okay.
Yes, sir.
So in same case, in case of Haskell, we are mainly used this map as a function. Okay, it's called as a higher order function.
Yes.
Basically, it is using a array with a another function. This is the most important part. The map mainly in case of Haskell is a higher order function. It means that we need a function that will be implemented over an array or a list. That is the most important part of the map. Because why I'm talking about map? Because in case of whenever you go to the functor class, there we'll understand that functor is implementing the map as well as the FMap. Why it is using map and why using FMap. So I'll just brush up the what is a map. Okay. So just I'm giving another example is that whenever I'm using a map command, okay, so we are using a function. So when we are using a function, so map defines it that a map with a function name. That means suppose that you can give an argument. Suppose I'm sharing one of the program. Okay. Now all of you can see that. Hello, Devasis.
Yes.
Sohan, can you see this? So here what
Yes,
I'm
sir.
showing you, just I'm giving you basically what is this map. Here I've defined it that map is a higher order function that requires an array and another function. This is what I'm defining here. Just look at it here. Whenever you are defining a map, okay, so here I'm defining a module name called as MQ. Clear? Where I define it that MQ is having two arguments, that is x and y. So what is MQ? MQ is a function. So equal to where I define that map within bracket x and y. What you can see here, I'm defining here. You can see here. Here define that map means A pointing to B. That's a function which is pointing to a list of A to B. That means when we apply the function A to a list B, So automatically it will be the list value will be generated. Automatically the value will be generated same as the A. So here what I am defining here, map I am defining here, map cube. Map cube I am defining a user defined function name with two arguments, that is x and y. So what you can see here, when I am passing the value argument, now what you can see that in the main function I am defining that map cube with within the bracket means what I am passing here, 2 I am passing. Okay, so 2 I am passing with 1, 2, 3, 4. What you can see that I am passing with 2 with 1, 2, 3, 4 list. Now suppose here just I am compiling and opening the GIS editor. Then I am just compiling it. What the name is that? Map then price dot hs. Okay. So once I completed the module 1 is successful, simply I run the main program. Now what you can see that I have passed the value here what? 2. Now you can see that each value 2 is multiplied with 2, 1, 2, 3, 4. So first value is that. Now writing here multiply 2. Sorry. Here you can see that I'm passing the 2 value. Here the 2 value is passed here. What is written here? Map. What is the within the bracket? What is written here? Sohan.
To the power x.
Devasi sir. What actually written here? Sohan sir, Devasi sir.
To the power x.
To the power x.
Yes.
Then what is the another value written here?
Y.
Y. So now the 2 is where it will map to the x, to the power x.
X.
Okay. And
Yes.
the list is passed to the whom? Y.
Y.
Clear? Devas clear?
Why? Yes.
Yes.
Okay. Sohan sir, clear?
Yes, sir.
Okay. Now tell me the answer. Here I am passing the argument map with a function I am passing to the here and a list is passing to the y.
Yes.
So automatically here x value is 2 and the y value is the list.
Yes.
So when it come to here, what the value here?
2.
First value is what?
To the power 2. Yes.
So to the power 1
One.
to the what is the value here? 1. Then to the power 2 is what?
4.
4.
Then
3 to the
last
power
one is
2.
what? Output? Tell me.
3 to the power 2. 9.
9. Then
16.
16. Now you can see the output here. I'm writing here, compiling it, and I'm giving the output. What the output here?
14916.
Got my point?
Yes.
This is called map. A map means this is having what you define as a key. Here a function is defining as a key which is always used with list. So list means the function is always operated over the list. What type of function you are using? Whether you are using this symbol, whether you are using, suppose I am passing what? Now into symbol. Clear?
Yes.
What is the output here? Devasi sir.
6,
So
2,
here on the
4, 6,
8.
8.
okay, perfect. Clear?
Yes.
Any doubt, anyone?
No.
Devasi sir?
No, sir.
Okay. Now, just we have clear actually why we are using map. In case of Haskell, we are using the map as a function that key is using with a list. Okay. So now whatever been I'm defining here, this is the basically concept of map. Now just I'm transferring to a functor. Okay. So whenever I'm trying to go to the functor, okay, functor, what I'm defining here, functor is also a type class. Clear? Functor is also a type class that provides two methods. One is FMap, one is this. What is this that we will discuss? That is applicative that we will discuss later on. So functor is also using a FMap as well as map. Both it is using FMap as well as map. But the difference is that what functor is defined here, in case of FMap, whenever you are using FMap, we are using some keywords, basically the functor classes, just like you can say that may, maybe, tuples, lists, all these things we are going to use in case of functor. So here, what we are going to define here, I'm just showing you here, map with plus 3, 1 dot dot type. What is the meaning of 1 dot dot type here? So answer
1 to 5.
1 to 5. Okay. Now, in case of here, in case of map, what I'm defining that map is adding the plus 3 to 1 to 5 means first one is 3, then 5,
3 to
then,
8.
then automatically it will added. Got my point?
Yes.
But in case of functor, what is defined that it is using some keywords. Basically, we can say that just, nothing, and maybe. It is using the keywords. Okay. So
Yes.
these keywords cannot be used in case of map directly. So that's why FMap is using these keywords, just like just, then the nothing, then the maybe. So today we'll discuss about what is just and what is nothing. So map already have discussed. Now suppose I'm writing a program here. Map subtract 1, 2, 4, 8, 16. Then same command I'm writing FMap subtract 1, 2, 4, 6, 18. So what is the output, both of the output?
1, 3, 7, 15.
In case of both output, clear?
Yes.
Again question arises. What is the output of both? The map and FMap, the output always return the same.
Yes.
Okay, the functionality is also same.
Yes.
Major difference is that we cannot use map directly with the keywords called just and nothing. Just I'm selecting here. You can see here. Just and nothing. This is the major difference here. What do we see the difference? That the between map and map, the difference lies is that functor enable us to implement some more functionalities in different data types such as just and nothing. So in the just and nothing, these data types cannot be directly used with a map. That's why the FMap means functor map. F means the functor map is using these keywords or the data types to operate. Clear?
Yes, sir.
So, sir, Terasi sir, clear?
Yes, yes, clear.
So now, just I'm going to show you, and the programming is there here. Previous classes, we have already discussed this concept.
Yeah.
So just a repeat, because Devasi sir, you do not have a knowledge on also map concept. Today I'm just clear about what is map and why you are using FMap in case of functor. So here what I am defining here, I'm using the just keyword and one is nothing. Okay. So in previous classes we have discussed. So what is the use of FMap? Means here we know that this is a function.
Yes.
And just is a what? It's a data type of functor.
Functor.
Nothing is also data type of functor. So just 10, we are defining as a just 10 means that the value is 10. Now we are adding plus 7. So what is the output here?
17.
17.
Yes.
Second case, you can see that I'm also using a nothing keyword. Then I'm adding the +7 with a nothing keyword. Then question again arises, what is the output here? Whether it is a
Nothing.
+7 or whether what is the output?
Nothing.
Nothing. Then question is arises, what is nothing?
Nothing.
Nothing means not to do anything.
Yes, nothing means not to do anything in case of the map. Means it is basically not giving any value like 0 or anything else. Okay, it's giving nothing. Just very
Yes.
simple example. If you have a knowledge on data structure, Ton sir, you have also knowledge on data structure.
Yes, sir.
So in the data structure, we know that each node contain a value and the address of the another node.
Another node, yes.
Yes, but at the last node, which contains the value, but it does not contain the address of any other node. That means what it contains? It contains nothing. That's a null value.
Yes.
That means nothing. Because these keywords mainly used whenever we go for the Plutus programming, whenever we go for the blockchain programming, there we create some nodes where we define the nodes. Inside the nodes, we define the values. And at last, we define that value, that last node does not contain nothing. That means the end of that particular nodes. So just forget it. I'm just giving a basic example, but we'll discuss later on. So here, what you define here. So whenever you define FMap with this value, then it's giving the 17. Here it's giving the nothing. Let's compile it and check it whether. So colon L, then just the file name is JustNothing.hs. So it's not showing any errors. Now simply I'm running the program. So you can see that just 17 and nothing.
Yes.
Again, so previous classes we have already discussed. Again, question arises, can you add more values here using comma operator? Okay, can we use more values using comma operator? Just like
Yes,
just,
yes.
just now we have already discussed. What is this called here?
Array.
What is this called here? This is
Array.
called a list.
Yes.
And list is separated by a comma.
Yes.
Okay, clear. So here what you define that we are using a keyword just having 10, 20. Now we can define that I'm defining the just within the square bracket or in the parenthesis bracket. See the code. I'm defining the 7 inside a which bracket? +7
So the
parenthesis.
parenthesis, yes.
That means indirectly and directly it is called a function. Same way, just is also defining within what? Square bracket or parenthesis. Devasis sir?
Parenthesis.
Parenthesis. That means it is also a function.
Yes.
Okay. So whenever a argument is passed from a function to another function, so here you are passing a single function and it is having two values. So question again arises. Whenever we are passing a 7 plus 7, then it will, in case of list, what previous classes, what just now we have already discussed. In case of list, whenever you are defining the 2, so it is adding to the list each element of the list. Yes or no?
Yes.
Yes, sir.
Yes. This is the most important point. You remember, whenever you are using a function that is 2, here we are using the multiplication to the list y. So that 2 is multiplied with each element in the list. But what you see here, we are defining a function with another function whenever we are using the +7. So question is arise that the output will be the 17 and 27. Yes or no?
Yes.
No.
No, 17.
No.
Okay, Devashish sir, no. Son Pandey, Son sir,
17.
can you explain me why yes or no?
No,
Why? Then what is the output here, Son sir?
only 17.
Only 17. then I have given also comma 20. That means it will be, if 20 will not be used, that automatically it will be a compiling error or a runtime error.
Yeah, it makes it better.
A function means, just remember, in case of a constructor, whenever you are passing it a value to another function, what you define that in case of a default argument is there.
Yes.
Okay, default argument means what? Whenever you have two values are there, if you define with a value, that means if the function is having only one argument, then default value will be remain the default value, then the value, another value, which is a single value, will pass
Yes.
to the another value.
Yes.
So in that case, whenever you are defining it, so which value you make it as a 0 or 1? Always you make the left hand side value as a value
Yes.
or right hand side value as value. You define that within the bracket x is equal to 10 comma y. Okay. So
Yeah.
whenever passing a function from 15, so 15 will added to where? X or y?
Why? Sorry.
Y. Because this is a function. Function means this is a bracket. Bracket means according to the associative law of the operator, some operator will operate from left to right and some operator will operate from right to left.
Yes.
Just like we are writing x is equal to 10. The 10 you will be assigned to the x. This is the associative law. Okay, that means here the operation is right to left. The constant is assigned to the variable. Same way, whenever you are using the bracket means what? The bracket is used as a function. That means the operation inside the bracket will always work from right to left operation.
Yes.
You have already discussed in C, C++, Java, .NET, PHP, Python, everywhere. The concept is same. It is not differentiated because this is the rules of language. So we cannot violate the rules of language. Son sir, clear?
Yes, sir. Yes, sir. Clear.
Okay, Devasys sir, clear?
Yes, yes, clear.
So whenever we are passing a 7, that means that the 10 will be remain as 10.
10 and 20,
Then the
27.
plus 7 will be added to the 20.
To 27.
That means the output will be what? 10, comma
27.
27. Clear?
Yes.
Let's run the program and check out whether it's right or wrong. Is no compiling error?
Yes, sir.
Now run. Now check it. Now we can see that what is the output here? 10 and
27.
27. So whenever simply I'm just writing a basic, just I'm writing a basic C programming here. What you remember, whenever you are writing any function in C++, and wherever you are writing that, you are writing a function number, suppose you are writing a swap function, you are writing x is equal to 10, then y you are defining. Yes or no?
Yes.
When you are calling the function, what you are writing here? Swap, suppose you are passing 5. Suppose another swap, you are passing 10, comma 3. Got my point or not?
Yes, sir.
Remember, here the value is already defined as a constant.
Yes.
If this function, this calling function, calling the call function, then automatically it will assign to whom? To
Y.
the y. But here what happened? It will be overwritten. But we should not think about all these things.
Yes.
So this means what? Here the same operation is doing here. What it means that the clause 7 is what? Overwriting, sorry, adding with the
20.
value. Clear? Any doubt is there?
No, sir.
No,
Yes, sir. Any doubt is there?
no,
Now, so this is the another point. Suppose I am using another command, command 30. I'm using 3 value. The question again arises. What is the output here?
37. 10, 20, 37.
10, 20, 37 as per the sponsor. Okay, that is sir.
10, 20, 37.
10, 20, 37. Clear? Okay,
Yes.
let's check the output. Clear?
Yes, sir.
Okay. So you are now conceptually clear actually how it is working.
Yes.
Any doubt?
No.
Okay. Now again, just moving to the up. Okay, functor class. Here I am just asking you that major difference here map and FMap. We have already discussed that only FMap whenever you are using any data type that is just or nothing, we can use the FMap command. Okay. Second question arises. Okay, clear. I'm using that. Okay.
Yes, sir.
Now, what is the output here? Just
Error.
what's the code?
Compilation error.
Compilation.
How can you find that compilation? I'm not going to compile. Okay,
Huh?
just see the editor. Just watch the editor. What you
Yes, tell
see
me.
when I
Red
remove the
underline.
F, what happened?
Red underline.
Okay, got it. Very good. Okay, okay, let's check it. Now you can see that what is defining that whenever you are writing a FMap plus 7, just 10, 20, 10, in this statement do block, whenever you are trying to print FMap with the just data type, it will not
Yes.
work. Because just data type is not mapped with the map. It is only mapped with the FMap.
Hmm.
So we cannot use it. That's why map and FMap both are same concept. The major difference is that FMap is only used in case of functor class where it is using the keywords or the data types of the functor just like just, nothing and whatever the rest of the keywords are available. Clear? Otherwise, output of both are same. Okay?
Yes, sir.
Okay. Dharmendra sir, Narendra sir,
Yes, sir.
we'll continue or we'll just close the topic here.
No, sir, you continue, sir.
Continue. Because lots of things are available so that I can continue. Okay. Okay, sir. Thank you, sir. So now, so question again arises here. What I am defining here. So you got the value. Okay. Here I am defining here map also plus 3. Here FMap also we can use it. But FMap only use in case of just keyword. Okay. Now, another most important part is that whenever you are using any other functions, keywords, here we are using this symbol. Okay. Whenever you are using this, we can say that in case of using some different, means we are not using any such keyword called FMap or whatever thing. So we can use with another concept called as applicative functor. What you can see here, we are using the keywords are what? FMap. Okay. FMap we are using here. But now question is arises, suppose I am not going to use the keyword FMap. Then what I have to use it? Here I have to use, that is another two concept, that is pure concept and the symbol concept this. So what you can see here, whenever I am using this FMap, now you can see that whenever I am using the functor class, here I am using the FMap plus 3 just 2, then 2 it adds to the plus 3, that means the output will be the 5.
Yes.
But whenever I am not using the FMap, question again, now I am not using the functor class. Yes, we are using the functor class. FMap is defined inside the functor class, but whenever you are not using the map, then it is called as a applicative functor. This is called as a applicative functor. Okay.
Yes.
So in case of this applicative functor, just I am giving you one example here. It is simply a normal functor. with some extra features provided with the applicative type class. What is the extra features? Here we define that it is called as a class functor pointing to a applicative functor where a pure value is always equal to, okay, where a is pointing to function a. That means when function is pointing to a b is equal to function a functor a pointing to functor b. Here the pure function is used as this symbol. This is the symbol we are using as this as a pure. This is the pure. Okay. Now here we can see here whenever I am typing here now, what you can see here, it is always remember that now we are using the import keyword controller.applicative, that we have to use this keyword. Okay, this is the import. We have to, what is the meaning of import? There is sir, Swan sir.
Include the include the other library files.
Okay, very good. Import the
Very good.
library function from the any other defined classes or any functions. Okay.
Yes, sir.
So control.applicative is available here where we define that integer pointing to integer, and f1 I have defined as a 3 integers. Okay.
Yes.
So here you can see that whenever you are writing a bracket, you can also write a bracket. In some of the function, whenever you have somebody else writing that, okay, discuss later. But you can define that f1 having two elements. Okay, where 2 into x plus y means 2 into x y means it will be multiplied, 2 will be multiplied with x plus y. So now you can see that whenever I am using the show command, show is basically a keyword which is used to give the output in the print case. Okay, here I am using the dollar, okay, f1, and here I am defining, this is the applicative form. Here you can see that. Here you can see that. Okay, this is basically we are using this symbol to add in place of FMap. In place of FMap. Then we can add it that plus 3 will be added with the just 3. Then output will be automatically 5. Okay, now we check it the output. Sorry, before I'm showing it. Now, you can got the value.
Yes.
What the value we have got it?
5.
5. Devasi sir.
Yes, got it.
Okay. Now, here have I, whether I've used the FMap or not? No.
No.
I have using symbol. This
Applicative.
is the pure symbol what actually we are going to use here. Okay. That's why in place of whenever you are using any symbols in place of FMap, then it is called as a applicative functor. Okay. But this is called send. What we define here, that applicative functor is a normal functor with the same extra features provided with the applicative type classes. Because whenever you are using these functors, then we have to use this applicative type function. This is the called as pure function. Okay. Now, so here now again we are defining here what is written here.
Star plus
Can you say
star 2, 3, 1, 2, 3.
Just I'm typing here. Here,
Yes.
this is a very good example. Now, so before I compiling, okay, let's compile it. Okay, successful compile. So before I run it, I need the output of both from Soham sir and Devassi sir. Soham sir, please say the answer.
2 minutes for you.
First, just one question. Okay, just go for that statement. What I define here inside the statement, define what the statement is there. Explain me first. Devassi sir,
You,
First one is list, under list, start to parenthesis mean one function, comma +3 another function, and then functor, applicative functor.
okay, just forget about this. Okay, just tell me. This is a list, this is a list.
yes.
Yes,
Okay,
yes,
both the Soham sir and Devassi sir. Then
Yes,
question
sir.
is there, what are the two different lists?
There is
What
a list of
is this list and what
methods.
is this list? Hmm?
List of methods or functions, sorry.
function,
Okay, list of functions. And second was the only list.
list,
They recall what is a FMap. FMap define what? A function is always
return function,
what? Added to a list.
Yes.
Operated over a list. Operated means it will give in the +2, it will each element will be added.
Yes.
It will give multiplied to, then it will be each element will be multiplied. In case of this, whatever we have till now discussed, basic,
Yes.
that is a basic map function we have already discussed here. Okay,
yeah, the
two means
first one.
the here I'm defining here. So just I'm moving the map price. Okay, in the map part to define that two. This is a function is each element will be what? You can you see this?
Yeah, yeah,
So here what I'm passing here, I'm just backing to the map concept.
Yes.
Two is a function and this is a list.
Yes, sir.
Here what I've defined that when you're passing the two is in the x. X means what? This is into multiplied 2 with y. Y is a what?
right,
List. Then
list,
here what's that? 2 is multiplied with each list
each
only
element
the
of the list.
okay, each element of the list. Got my point. Okay, thank you. The next point is here. What you define here? Here is the define the list, and here is
List.
also list. But inside this list, what you define here?
Two function,
Two function. Then applicative. You may use applicative. You may use FMap. You may whatever doesn't matter. Now we are clear. Okay.
yeah,
Or you can use also simple map concept. So whatever thing we are going to use. So here what we can define that this is a function, a list contains two functions. The first list contains two functions and second only the list. Then my question is that if I compile, it will not show any compile error because I have already shown you.
Yes.
yes,
So my question is to both of you that what will be the output of both this list?
2, 4, 6, and second one is 4, 5, 6.
Okay, thank you, Devasi sir. So sir.
Sir, my answer is like 5, 5, 7, and
5, 7 and
5, 7, and 9.
5, 7 and 9. And again, my question to Swan sir.
Yes.
So later I talk to Devasi sir. Swan sir, how you can define that 5, 7, 9?
First, I applied first list function, first start to start 2, then I again applied +3.
Then you are saying, you are just telling that
Yes.
first 2 is that it will the 2 into 1 means 2 plus 3 means it will be 5.
Yes.
Okay. So as per the shown chart, the first output will be the 5, then
7
7,
and
then
9. 9.
10. Okay. But Devasith sir, please tell your answer.
2,
2,
4, 6.
4, 6,
And for the second function, 4, 5,
4, 5, then 6.
6. Yes.
636.
Yes.
Okay. So now you have both have the contracted output. Okay. So now, okay. So we have already discussed that each function value of that. Now, suppose I'm going to run the program. Okay.
Yes.
Whose answer is right?
2, 4, 6, 4, 5, 6.
Devasith sir or Son sir answer is right.
Yeah, this one not 3, this one 4, 4.
Yeah. No, you are okay. Doesn't matter.
4, 5, right?
Yes.
So, Son sir, you know what is the mistake you have told there?
Yes.
Devasith sir, you are right, 100% right, because Devasith sir already cleared the concept. Son sir, you have just basic knowledge. So
Yes.
just give a preview. So I told you previous in the math that every function is always operated over a list.
Yes.
Same concept here. If a list is having two functions, that means the first function will operated over the one list, then comma, then second function will operated with another list. That means there will be the two list output because there is two function separated by comma and that will define inside a list. So indirectly, it is a list of functions.
Yes, sir.
List of functions. That's always you have to remember. Okay, Devasith sir, you have already cleared this concept. So
Yeah,
this
okay.
is the list of functions. Means inside the list, a function, a element is a function multiplied with the another list. Another function that is called summation are added with the list. Then output will be simply like a single list. This is 2, 4, 5. Then output is the same. Clear?
Yes, sir.
Okay. Any doubt, both of you?
No,
No.
sir.
Okay. So today we will have to close the topic here. Okay. So next class we will go for the same concept regarding the functor class. We will go for the applicative, and that is always another concept called the monoid concept. Then after that we'll discuss other factors, other reference. Okay. Okay. Thank you. Narendra sir.
Yes, sir.
Sir, just I have completed the functor and applicative functor. So we have already discussed about examples and all the things. So we have to close the topic.
So, are we giving some home task to the people?
Sir, let them cover it, then next class I'll give the task.
Okay. Okay.
Okay, sir.
Yes, sir. Thank you, sir.
Sir, any doubts in that? Clear?
No, yes, clear.
Yes.
Okay, fine. Okay, thank you to all of you.